Hello student, welcome to Chatterjee Academy. Today's session is on half wave rectifier and full wave rectifier. So what is the use of this rectifier? So rectifier means whenever we are applying an AC current in a circuit, we will be getting the DC current. Okay. So this rectification I will explain you now. So there is an AC source, the alternating source of current. This is AC input and this is the step down transformer, right? So this is the primary coil and the secondary coil. So AC current is coming to this circuit through step down transformer. Now what's happening that this is a PN junction diode. This is the P type and the N type. Okay, so whenever AC current having it's an wave nature, right? It's having a two cycle. First half cycle the current is flowing like this. In the next half cycle, current will flow in this opposite directions. Current will flow in the opposite directions. Okay, it's a positive half, it's a negative half. So let's assume in the positive half, current is flowing like this. So in the first half, it's a battery acting. The P positive terminal of the battery is towards the P type. So current is flowing towards the P type. Means the positive terminals will be the P zone and the negative terminal will be the N type zone. Okay. So this will be treated as a forward bias. So in the forward bias circuit, the current will flow in the circuit. So we are getting an current output. We are getting a DC current in the first half cycle. And what happened in the next half cycle? When the AC current reverse in this diode, the polarity is getting changed. So the P part of the diode is connected to the negative terminal of the current of the circuit and the N type connected to the positive terminal. So this diode will be treated as an reverse bias diode, right? So we know that in case of reverse bias, there is very low current is passing, almost no current. So in this output, we will not get any current. We will not get any DC input over here during the second half of the cycle. Again, when there is a positive cycle, we will again get the current since PN junction diode will be connected to the forward bias. In the next half cycle of the alternating current, the PN junction diode will get the reverse bias circuit, so there will be no current. So this way we are preparing the half wave rectifier. So we are getting a DC voltage across this resistance load, okay, DC voltage, and this is an half wave current. So we are getting DC current here, the next half cycle no current, we are getting current here, next half cycle no current. Now for the next step, so now I will explain you the full wave rectifier. Okay, so for full wave rectifier, let me show you the slide over here. So full wave rectifier, what we are doing, we are having the similar circuit. So the input is the alternating current and this is the primary coil, secondary coil. So we are getting a step down current in this circuit. Here we are adding one more diode. Initially there was one diode. Now we are adding the diode 2, D1, D2. So what's happened? When in the first cycle of the alternating current, we are getting a positive terminal in P, negative terminal in N. So this diode D1 will be under forward biasing circuit. We will get a current for D1 diode. And the next half, we know that in the next half, this diode will be in the reverse bias circuit because the next half, the direction of current getting changed in alternating input. But this diode, it will be in the forward bias in the next half of the cycle. So for this diode, we are getting the current in D2, the current in D2. Again, the next half, we are getting current in D1, again in D2. So this way, we are getting the full rectification. So it's called full wave rectifying of the alternating current to DC voltage. And each time we are getting the DC output in the across this load, the same load we are using for the two cycle. So in the first half, diode D1 under forward bias. In the second half, diode D2 in the forward bias. Due to this, we are getting a full wave rectification. Okay, so this is a very clear concept go and understand the concept. I believe if you follow my session, it will definitely give you a concept about this. Now if you ask me what is forward bias and negative bias, which already I have explained, but let me go back to explain it again. Okay, so okay, let me help you to understand few more slides. I believe it will help you, right? So if this slides is visible, I believe here this is an example of the the PN junction diode. Let me show you one more slide, which will give you more clarity. Yeah, this is a forward bias circuit. So the P and N point, right? So P is N. So what happened? We are giving the positive terminal of the battery here, and we are getting the current under forward bias. One more slide I will explain you here. So this is more zoom. It will help you to understand in the the basic level. So this is the P type semiconductor, N type semiconductor. Now if you ask me how does P type semiconductor and what it is? P type semiconductor means there is a high concentration of the holes. N type semiconductor means high concentration of the electrons. So these are the extrinsic semiconductor. We are adding some doping. So we are doing some doping by pentavalent and tetravalent atoms. We are adding the tetravalent atom for P type doping. For N type doping, we are adding the pentavalent atoms. So by this doping, we are increasing the concentration of the holes and the electrons. Okay. So after doping, what happened? This PN junction then here, the depletion layer is formed because the holes is trying to move in these directions and the negative ions electrons are trying to move this direction. Here there is a depletion region formed. Okay. Now whenever we are adding this PN junction with the positive terminal to P, negative terminal to N, we are getting the forward bias because the holes are trying to move in a faster high speed toward the N terminal and the electrons are trying to move in the P terminals. So they will recombine very fast, and the and the net result is we will get a flow of current in the forward bias. Okay. And now what happened in reverse bias? The depletion region is getting more thicker. Okay. So this is the reverse bias circuit. If you see here, the PN junction. So let me show you one more good slide for the reverse bias. Okay. Yes. So here if you see the P type is connected to the negative terminal, N type is connected to the positive terminal. What happened? That the positive holes are coming toward the opposite and the negative also coming to the opposite. Depletion layer will be more wider. So there will be very less amount of current in the reverse bias. Okay. So I believe this is all about the forward and reverse bias. And so if you see here, that it's called knee voltage in case of forward bias. In forward bias, as I already told you, we're adding the positive terminal of the battery to the P type. So depletion layer getting thinner and there is a flow of current. So there is an the potential barrier voltage. So once we are adding the voltage, we are increasing the voltage is goes around 0.6 to 0.8 volt approximate. The current is suddenly gone up. Okay, so this is called the knee voltage. Whenever we are giving the voltage more than the knee voltage in the forward bias circuit, we are getting a good amount of current. So this is the forward bias characteristics of the PN junction. Okay, so that's it for today. Go through it. Any question, please reach me through WhatsApp. Okay, and I'll help you by taking more session. Please watch my session, and if you like, please subscribe. Okay, thank you.